Okay, right. So please note down this diagram now. Okay, note down this diagram. Okay, noted down. Fine.
Yes, sir.
Is it over?
No,
Over.
sir. I think
Okay, please write. Please write.
so.
Over. Okay, right. Okay, write down. Figure shows. Figure shows. Figure shows a simple hydraulic system. Figure shows a simple hydraulic system. A liquid entering. Figure shows a simple hydraulic system. A liquid entering. A liquid entering and leaving a container. A liquid entering and leaving a container. A liquid entering and leaving a container. Okay, right. Now please observe, in this case, okay, in this case, the liquid in the container, okay, so just observe, liquid in the container can be called as what? Can be called as hydraulic capacitance, hydraulic inertance, or hydraulic resistance. Liquid in the container is what? Basically, which stores? Liquid in the container is going to store the energy, and it is going to be called as what is called as the hydraulic capacitance. Okay, and a valve which is going to be present here. Okay, this is the valve. Okay, what valve is going to be used? Okay, valve is going to offer the resistance to flow. Correct. Okay, it offers the resistance to flow, and this is going to be considered as what is called as the hydraulic resistance. Okay, right. The liquid in the container, the liquid in the container, as it is a fact that it is going to be used for the storing of the energy, it is going to be called as hydraulic capacitance, and the valve, okay, which is going to be used to resist the flow, okay, can be considered as the hydraulic resistance. Okay, and the hydraulic inertance, okay, hydraulic inertance is neglected here because the flow is going to be more or less standardized. Okay, right. Now this is the initial case. Now what we need to do is we need to give a relationship between what is the relationship with the discharge, that is the entry Q1, and what is called as the H. H is nothing but the height, okay, of the liquid in the container. Okay, now this is what is the relationship that we need to make it up. Okay, right. Now we have what is called as a capacitance or the capacitor, and we have what is called as a resistor or the resistance. Okay, right. Now we shall write the equation. We shall write the equation for these two cases and combine together so as to get the main equation. Okay, right. Now we shall write for capacitor. Okay, now you just go back and check the last class work what we have done with respect to the capacitor. Okay, what are the capacitor equation? What are the capacitor equation? Now we have, if you observe, Q1 is what now? Q1 is the amount of water entering into the container, and Q2 is the amount of water leaves the container. Okay, right. Therefore, the amount which is stored in the container is how much? The amount which is stored in the container will be equal to Q1 minus Q2. The amount which is stored in the container will be equal to Q1 minus Q2. that will be equal to C into, okay, C into the dP by dt. Okay, right. So we shall call this as equation number 1. Okay, right. Now, next thing is, what is the value? What is Q2 here? What is Q2? Q2 is what? Please note on this. Note down this first. For capacitor, Q1 minus Q2 is equal to C into dP by dt. For capacitor, Q1 minus Q2 is equal to C into dP by dt. Okay, right. Now, the rate at which, next line, you right? The rate at which the liquid leaves the container. The rate at which liquid leaves the container, that is Q2. Q2 equals the rate at which it leaves the valve. Is it right? Okay. So this is very, very important. Okay. The rate at which liquid leaves the container Q2 equals the rate at which it leaves the valve. Okay. Therefore, for the resistor, what is the equation for the resistor? What is the equation for the resistor? What's the equation? Can you please tell me the resistor equation? Basic resistor equation. In the basic building block we are done, na? Tell me the basic resistor equation. Quickly, you have to just observe and tell. The basic resistor equation.
R is equals to Q1 by P1 minus P2.
It is P1 minus P2. Sorry. P1 minus P2 is equal to what? R. Correct? Yes, sir. What? R into?
Yes, Q.
Q. Now here, what Q? Which Q it is?
Q2.
At the valve, which Q is there?
Q1, sir.
Q. Okay, at the valve, it is R Q2. P1 minus P2 is equal to R into Q2. Okay, right. Now, what is this pressure difference is due to? P1 minus P2 is there. Now, this pressure difference is due to what? Is due to the water level in the container. Yes or no? Are you understanding? The pressure difference is the pressure due to the height of the liquid in the container. Okay, write down that. The pressure difference P1 minus P2 is the pressure due to the height of the liquid, due to the pressure due to the height of the liquid in the container. Okay, in the container. Okay, right. What is P1 minus, what is P is equal to in terms of H? Can you give me the equation? P in terms of H. What is the basic equation? Some basic equation should be known to you, yaar. Huh? What is the relationship between P and H? Pressure and height. What is the difference? What is the equation?
P
What is
equal to
Pascal's
mg.
law? What is Pascal's law? P is
P
equal
equal
to?
rho GH.
Very good. Okay, so P1 minus P2 is equal to what? Rho G H. Is it correct? Okay. Therefore, we'll replace this. Rho G H is equal to R into Q2. Okay. Is it clear? This rise to Q2 is equal to what now? Q2 is equal to rho GH by R. Clear? Is it clear? Yes or no?
Yes, sir.
Q2 is equal to rho GH by R. Substitute substitute the value of Q2. Substitute the value of Q2 in equation 1. Substitute the value of Q2 in equation 1. Okay. I am moving to the next page. Have you taken up till here?
No, sir.
Write down, please. Write down. Substitute the value of Q2 in equation 1.
Finish, sir.
Okay. Shall I turn the page?
Yes, sir.
Okay, right. So what is the equation 1 now? What is the equation 1? What is the equation 1? Tell me.
Q1 minus Q2 is equals to C into dV by dt.
Okay, right. So Q1 will write as it is. What is Q2?
Rho GH by R.
Rho GH by R. Okay. That will be equal to C. What is P? P is what? P is what? What is pressure? Huh? Pressure. Rho G H. Yes or no?
Yes, sir.
Okay, right. But what is capacitance C? What is capacitance C is equal to? What is this constant? What have we replaced? Go back to the second
A by
building.
rho.
A?
By rho.
A by?
Rho into G.
A by rho into G. Correct? A by rho into G. Therefore, Q1 minus rho GH by R is equal to, in place of C, you write A by rho G. Okay. In this case, rho G is constant, dH by dt. Okay. So rho G gets cancelled. So Q1 minus rho GH by R is equal to A into dH by dt. Okay. So we'll rearrange. Q1 is equal to A into dH by dt plus rho GH by R. Okay. So this equation describes how the height of the liquid in the container. What is this represented as? What is the height of the liquid in the container?
H.
H. Very good. Okay. Height of the liquid in the container H depends on what? Depends on the rate of input of liquid. What is rate of input of liquid?
Q1.
Q1. Rate of input of liquid Q1 into the container. Okay. You understanding? So this is with respect to Q1. Okay. And what is called as H and H. Okay. Is it clear?
Yes, sir.
Okay, right. So this is an important derivation, okay, which shows how the height of the liquid is dependent upon the rate of input, okay, the rate of flow, okay, that is Q1. Is it clear now? Shall I proceed further?
Yes,
Shall I
sir.
proceed further? Okay. So I will turn the page again. Okay. So we shall go further. Write down. Next, example 2. Example 2. Write down. For the following figure, derive an expression for the following figure. Derive an expression how the height of the liquid. Derive an expression how the height of the liquid in the containers changes. How the height of the liquid in the container changes. How the height of the liquid in the container changes. Okay, right. So please underline the word how the height of the liquid in the container changes. Okay, that is very, very important. How the height of the liquid in the container changes. Okay, just write this diagram now. Okay, please note down this diagram. If you have any doubt, you just wait till I am going to finish off this diagram so that you will get a clarity. Okay. One is this height. Okay. Entry is Q1. The height of the first container is H1. Okay. And there is one valve here. Okay. Right. So there is one valve here. And next is the same water actually. Okay. Right. The height differs now. Okay. This is H2. H2. And there is one more valve here. Okay. Right. Q1. Q2 is going through here. Q3 is this. Okay. This is cross-sectional area A1. This is cross-sectional area A2. Okay. Please note down this diagram. Over? Over?
No, sir.
Not done, not done, no problem, not done. Clearly not done.
Completed.
Completed. Shall I proceed?
Yes, sir.
Yeah. Okay. Now just observe. I'll just describe this. Okay. Now here earlier diagram, how many height was there? There was only one container. Clear? Now here we have two different containers with the height of the liquid as H1 and the height of the liquid as H2. So we need to give a relationship between how this Q is going to be related to the height of the liquid. Okay. Right. Now Q1 is nothing but, just observe, Q1 is the rate of liquid entering into the first container. Q2 is the rate of liquid goes out of the valve. Okay. Then there is one more valve here. Q3 is the rate of the liquid goes out of Q3. Now, how many capacitance are going to be obtained? Tell me. How many capacitance here? 1 or 2?
2, sir.
2. Okay. Capacitance with respect to height H1. Yes. Yes or no?
Yes, sir.
Then another capacitance with respect to height H2. Correct?
Yes,
Okay.
sir.
How many resistance offered? At what places the resistances are offered?
2. 2 and Q3.
At valve 1, at valve 2. Correct? At valve 1, the resistance offered is R1. At valve 2, resistance offered is R2. Okay. Any doubt up till here?
No, sir.
Will you proceed?
Yes, sir.
Yeah, right on. The figure illustrates the hydraulic system. The figure illustrates the hydraulic system. The figure illustrates the hydraulic system. Full stop. Relationships can be derived. The figure illustrates the hydraulic system. Full stop. Relationships can be derived. Relationships can be derived which describe. Relationships can be derived which describe how the heights of the liquids, how the height of the liquid in the container, how the height of the liquid in the container change with time. How the height of the liquid in the container change with time. How the height of the liquid in the container change with time. Okay, right. Now we'll write for container 1. Writing as container 1. Okay, right. Container 1 with a height H1 is a capacitor C1. Thus for container 1, what is the equation? Tell me, what is the equation for container 1? Go back to the previous one and tell at least. For capacitor, what is that? Q1?
Q1 minus Q2 is equal to C into dP by dt, sir.
Q1 minus Q2 is equal to
C into dP by dt.
C. Okay, it is C. Now here, how many containers are there? 2 containers. Therefore,
C1.
Simple. C1 dP by dt. Okay, right. Similarly, where P is equal to what? We'll try to write in a similar line so that it is easy for you to remember. P in terms of H.
Rho GH.
Rho G H1. Correct, na? Correct? And C1. C1 is what? What is C1? C1.
A1 divided by rho G.
A1 divided by rho G. Good. Okay. Clear now? Clear? A1. This is A1 divided by rho G. So we'll substitute. Therefore, Q1 minus Q2 is equal to C1 is A1 by rho G dP by P is rho G H1. Correct? Correct? Rho G is constant. So this rho G is going to be gets cancelled. Therefore, Q1 minus Q2 is equal to A1. Correct? A1. Yes or no? A1 d H1 by dt. Okay, any doubt up till here?
No, sir.
Okay, so copy this. Call this equation number 1. You write down, copy this. So Q1 minus Q2, basic expression, C1 into dP by dt. We know P is equal to rho g H. So height is H1 and C1 is equal to A1 by rho g, which is constant. So we have substituted. After the substitution, Q1 minus Q2 is equal to A1 into dH1 by dt. We have called it as equation 1. Okay. Okay, right. Now, so we have Q2. Q2 is what? Q2 is what? Q2 is the rate at which, observe, Q1 is what? Q1 is the rate at which water enters the container, correct? Q2 is the rate at which water leaves the container. The water which leaves the container will be passing through what? Passing through the valve and it leaves. Okay, right. Right now, the rate at which the liquid leaves the container, rate at which the liquid leaves the container Q2 equals the rate at which it leaves the valve. Rate at which it leaves the valve. Okay, I am turning the page. At which it leaves the valve. Which valve? Valve what? Valve R1. Valve R1. Thus, for the resistor R1, P1 minus P2 is equal to, what is P1 minus P2? What? Tell me, P1 minus P2 is equal to resistor equation. Huh?
Rho g H1, sir.
Hey, allapa, resistor equation for resistor.
R1
R1 into
Q1.
allapa. Q1 is the entry. What is
Q2, sir.
Q2? Are you understanding? Don't mix the things. Okay. P1 minus P2 is equal to R1 is the resistor, first resistor, correct? Q2 is what? Q2 is the output at that resistance. Okay, at R1, Q2 is the output, correct? No?
Yes.
P1 minus P2 is equal to R1 into Q2. Okay, right. Now, we know what is P. We know that P is equal to what? Rho g H. Correct? Correct or what? Okay. Therefore, P1 is equal to rho g H1 and P2 is equal to rho g H2. Okay. Therefore, P1 minus P2. P1 minus P2, what is going to happen? Rho g, I will take it outside. H1 minus H2 will be equal to R1 into Q2. Is it clear? Okay. Therefore, Q2 is equal to, similar to the previous one I am doing. Okay, Q2 is equal to rho g H1 minus H2 divided by R1. Okay, right. Substitute the value of Q2 in equation 1. We get, okay, substitute the value of Q2 in equation 1. What is equation 1? Equation 1 was Q1 minus Q2 is equal to A1 into dH1 by dt. Okay, so I will write that Q1 minus Q2 Q2 is what? Rho g H1 minus H2 by R1 is equal to A1 into dH1 by dt. Okay. Have you noted up till here?
Yes, sir.
All of you?
Yes, sir.
Okay, right. Now below this you write, this equation describes how this equation describes how the height of the liquid. This equation describes how the height of the. Okay, one minute. Okay, below that. Okay, before that, you write Q1 is equal to. Below that, you write please. Q1 is equal to A1 dH1 by dt plus rho g H1 minus H2 by R1. Please write this because so that it is very clear now. Okay, Q1 is equal to, just rearrange. Q1 is equal to A1 dH1 by dt. Send that to the right side. Okay. Now, below this you write this equation describes how the height of the liquid in the container 1, that is H1, okay, depends on the input rate of flow. Is it clear? Clear now?
Yes, sir.
Okay. Any doubt up till here?
No.
Okay. What have we done now? Have we taken both the container into account or only one container we have done now?
Container.
Only one container. Okay, right. Okay. Next one. Continue. The same thing. Okay, we are in the same derivation. I'm continuing. Now write the subheading as what? What? Container 2. Okay. Right on. For container 2, now it is easy for you. For container 2, similar set of equations. Similar set of equation to be derived. Okay, this is for you to understand. Okay, to be derived. Okay, clear? Now, similarly, what have we done in the previous? Similar way you write down. Okay, write down please. Container 1, container 2 with a height. With a height what?
H2.
With a height H2. Q1. Tell me now. Q what?
Q2
Then
minus Q3
Q2 minus Q3 is equal to
C1.
C1 again.
Sorry, C2
C2 into dP
dP
by
by dt.
dt. Okay. Where P is equal to what? Rho G
Rho G H2.
H2. Okay. And C2 is equal to similar to the previous. I just want you to repeat so that it's easy for you. C2 is equal to A2 by rho G. Therefore, Q2 minus Q3, C2 is A2 by rho G into d by dt. P is rho G H2. Okay. Rho G H2. So Q2 minus Q3. Okay. A2. Rho G gets cancelled into dH2 by dt. Call this as equation number 2. Same lines you write, the same way. Next line. Over up till here.
Yes, sir.
Okay. All of you.
Yes,
Yes, sir.
Okay, right. Below that you write the rate at which liquid leaves the second container. Liquid leaves the second container. What is the value that Q? Q3. Right now. The rate at which liquid leaves the second container Q3. The rate at which the liquid leaves the second container Q3 equals the rate at which it leaves the valve. Which valve?
R2, sir.
Right now. Good. It leaves the valve R2. Okay, right. Next line. Thus, for resistor, I'm writing the same way so that it's easy. Thus, for resistor R2, what is that we wrote in the previous? Now you tell me P2 minus
P2 minus P3.
P2 minus P3, that will be equal to
R2 into Q3, sir.
very good. R2 into Q3. Okay. Now you tell me what is P3? What is P3?
0.
Huh? Tell me. What is P3? P3 is when? Well, no, you are sending that pressure to where? Are you sending it to any container or are you sending it to atmosphere?
Atmosphere.
You are sending it to atmosphere. Okay, right. So P3 is equal to 0 atmospheric pressure. Okay, P3, because we are measuring the pressure above the atmospheric pressure. P1, P2 are the pressure measured above the atmospheric pressure. So P3 you are sending it to atmosphere. Okay, right. P3 is equal to 0. Assuming P3 is equal to 0. Assuming that the liquid where what happens? The liquid exits into the atmosphere. Okay. Therefore, P2 is equal to R2 into Q3. Therefore, Q3 is equal to what? P2 by R2. Substitute the value of Q3 in equation 2. Substitute the value of Q3 in equation 2. Okay. What is equation 2? Q2 minus Q3. Q3 is what? P2 by R2. That will be equal to A2 into dH2 by dt. Is it clear? Have you done
Yes,
up till
sir.
here? Have you taken up till here?
Yes, sir.
Q2 minus P2 by R2 is equal to A2 into dH2 by dt. Clear? Right. Now, I want H2 to come in place of P2. Okay, what should I do? I want P2 to be expressed in the form of H2. What should I do?
Rho GH2 into
Very good,
H1.
very good. Okay, next line, next page. Okay, right. We know that right now. We know that P2 is equal to rho G H2. Therefore, Q2 minus rho G H2 divided by R2 is equal to A2 into dH2 by dt. Okay, A2 into dH2 by dt. Okay, right. Q2 is equal to, therefore Q2 is equal to A2 dH2 by dt plus rho G H2 by R2. Okay, over up till here.
Yes, sir.
Okay, this equation describes how the height of the liquid in the container 2 depends on the input rate of flow Q2. Okay, clear? Clear?
Yes, sir.
Okay, right. Now one more additional thing I am writing. Okay. Now write down for the container 1. For the container 1, what is Q2? The value of Q2 is, just go back. For the container 1, what is the value of Q2?
Rho into G of H1 minus
Rho G
H2 by
H1 minus H2 by
R1.
R1. Okay. Now substitute this into above equation. Okay. Into above equation. Okay. So in place of Q2, what I will do? I will write rho G H1 minus H2 by R1. Okay. Is equal to A2 into dH2 by dt plus rho G H2 by R2. Rho G H2 by R2. Okay. Right. Now what this equation gives you? H1 and H2. Okay. Both. Okay. This equation right now, this equation describes how the height of the liquids in the container changes. Okay. the container changes. Okay. Now I have combined both container 1 and container 2. Clear now?
Yes, sir.
We got clarity. Yes?
Yes, sir.
Okay, right. Now, any doubt here? Any doubts?
No, sir.
Have we copied up till here? Have we copied up till here?
Yes, sir.
Okay, right. Okay, right. So write down. Okay, write down the assignment. Write down. So explain the various building blocks, basic building blocks. Explain the various basic building blocks for hydraulic system. Okay, clear?
Yes, sir.
Next one. Okay, I want you to write the three hydraulic elements: hydraulic resistance, hydraulic capacitance, and hydraulic inertance. And write down, derive the expression, derive both the expression. Okay, I don't want to read that again. Video I already done. Okay, derive the expressions as given in example 1 and example 2. Derive the expression as given in example 1 and example 2. Are you understanding?
Yes, sir.
Okay, the purpose is simple. The purpose is I want you to write again the derivation. That's all. Okay, I want you to practice. Okay, right? So 3 elements plus 2 derivations. Okay, so neatly you write. Okay, and upload in the Google Classroom. Okay, how much time do you require? How much time do you require? Today is 25th. Tell me. Today is Wednesday, no?
Friday, sir.
Friday. Okay, fine. Good. Fine. Okay, Friday. Okay, today is Wednesday. So anyhow, tomorrow, day after tomorrow, I don't have class. So by the end of Friday, so please upload the complete hydraulic elements now. Okay, so you will have first stage hydraulic elements, second stage the derivation, so that the complete hydraulic elements will be clear. Okay, so now when we meet in the next class, we will do similar exercise for pneumatic system. Okay, again pneumatic system elements and followed by a derivation. Okay, so that will take, okay, slowly and clearly. Any doubt?
Yes, sir.
Clear? Shall we close the class?
Yes, sir.
Yeah. Okay. Right. So we shall complete the class today. Okay, and we will meet again in the next session. Okay, means maybe on Monday. Okay. So by that time, Friday, you please see to that you upload the material. Okay. Right. Okay. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.